With the explosion of cloud technologies in the mobile workforce, the corporate network perimeter has been redefined. As a result, today's organizations need a new security model that can provide secure access to their resources regardless of user or application environment. This means adapting to the modern distributed workplace, embracing the mobile workforce, and protecting people, devices, apps, and data wherever they're located. A zero-trust approach transforms the security model into one that verifies requests explicitly using all available signals, employs the principle of least privilege access, and assumes breach. This approach should extend throughout the entire digital estate. It should also serve as an integrated security philosophy and end-to-end strategy based on 6 foundational pillars. First, identities. Verify all identities with strong authentication. Second, devices. Get visibility into all the devices accessing your network. Third, applications. Discover shadow IT and monitor and control access with real-time analytics. Fourth, network. Encrypt all internal communications, limit access by policies, and segment networks. Fifth, infrastructure. Employ real-time threat detection, automatically block and flag risks, and employ least privilege access principles. Finally, data. Classify, label, and encrypt data to protect it wherever it lives or travels. Each of these 6 pillars is a critical resource to be defended. But where do you start? Every zero-trust journey is unique, so start by evaluating your current environment, available resources, and priorities. Every step forward will make a difference in reducing risk throughout your digital estate. To learn more, visit aka.ms/zerotrust.
Hey everybody, it's Jay. Welcome back to Azure Fun. Well, we talk about the people, the products, and the services that make up an amazing Azure experience. And this week, we're going to touch on another subject that we've been talking about a lot lately, and I think it's important that we keep talking about it, and it's security. And this week, we're going to actually talk about something that's a little bit different than we have before, but with a old face, or not old, but a face we've seen before here. I don't want to call someone old. That's not nice. But I've got a face that I think some of you will remember. I'm going to bring him in just a second, but I want to remind everybody, if you'd like to take part in the show today, there is a chat. You can use the native Learn TV one. You can use whichever form of communication with this show you are using. We want to hear from you. And that being said, I want to hear from this guy. It's Christos Matskas. Hi, Christos. How are you today?
This old face is back.
Yes. You know, I found a little something from the last time you were here. Geez.
Whoa.
You know, I got to be honest with you. You look exactly the same.
I'm keeping the theme. I even have a blue t-shirt. So, well, teal?
Yeah,
teal?
Look at that. Yeah. Anyway, so yeah, you're back again here, and I really enjoyed our last time getting together. You gave me a ton of amazing information about Azure Identity, and I think I learned quite a bit from you. And today, I think I'm going to learn a little bit more. And to kind of kick off what we're going to be talking about, I'd love to ask you, before we get into all the minutia of today's subject, I'd really love to hear what have you been working on? What are you passionate about? What's going on with you lately?
Well, we'll continue to try to educate developers about how to build secure applications, whether it's through identity, by offering a front door to the application and knowing who's coming into your solutions, so you can actually do some authorization and proper access control, to actually building secure apps that communicate with other resources and how to access those resources without compromising security. That's very important. And since security is continuously evolving, and since every solution out there is fairly unique, every solution is a snowflake in our eyes, because no one writes the same software in the same way twice. So even though everybody is accessing a database, They will be using different ORM systems. They could be doing direct access to their databases and so on. There's always a challenge there to help developers do it securely. And it's a continuous education for us and continuous education for our audience and our community.
So that leads me into the first kind of part of this conversation I'd like to talk about, which is something that we just touched upon in that video that I think is super, super interesting. And it's the zero trust principle. Yes. The idea that, and it sounds kind of like a double negative almost, but to be honest, it makes a ton of sense once you kind of go through it. So why don't we just step through some of these three big principles? All right.
Yeah, let's do it.
Sure. So the first thing that we're going to kind of talk about here in the zero trust principles is the idea that you should verify explicitly. So always authenticate and authorize based on your available data points, including user identity, location, device health, service, or workload, data classifications, and anomalies. What stands out for you about doing like verify explicitly in this particular case?
Well, since I work in identity, the fact that you have to authenticate and authorize at any point, at every point and any point, is probably the beginning of your verifying explicitly. I can't implement any security unless I know who you are, whether you're trying to access your bank details or whether you're trying to access your work systems and resources. It's very important for us to identify who you are. And then from that point onward, there's a whole slew of other features, as you say here, identity, user identity, location, like where is somebody logging in? If my work knows that I'm based in Seattle, if they see a login from Germany suddenly, they have to flag that up, right? Why is Christos logging in from Germany when this morning he was logging in from Seattle? That's very important. Then the device health, I get a ton of emails because I run multiple devices, and I'm sure you do as well. Update from MSIT, from Microsoft IT, saying update to the latest operating system, apply your patches, because otherwise we'll take your devices off the network. They won't be trusted to access resources. And that's very important. Thanks for those emails, MSIT.
Yes,
they keep me on my toes. And then you have the, because we assume that all devices have been compromised, right? I think we'll cover that later on. So by assuming that every device is compromised in our network, it means that our IT teams can quickly isolate those resources. So we don't assume that things are safe, especially in a cloud environment, right? We're not in the office anymore. We work from home. So how do people know? Like, how does the wider network within Microsoft or any other enterprise know that the user has not compromised the devices by downloading something?
And that's why this least privilege access principle is so huge. Because we don't want to oversubscribe our users to different rights that could come back and say, you know what, this particular user got compromised and they had access to actually destroy, say, a production database.
Yeah.
The amount of damage that can be done, especially with, restoring things, then securing everything again. We don't want to think about that later. We want to think about it right away. And so right here it says just enough access or just in time access. I know Azure provides a just in time service to use alongside, say, your virtual machine. So you can have a login just for a certain amount of time and then it expires.
Yeah, RBAC, resource-based access control, and going with least privilege. We've been pretty bad in implementing that, especially in the early days of the Windows and Microsoft, where we would, give you a server with everything unlocked, and you had to go and lock it down yourself because we assumed that everything was safe. But now it's very different. You have to start with everything locked down and only open the things that you need. And I think we've become a lot better. Like when you provision a storage account, we go with private, or we will prompt you for private access first before we give you public access, because we don't want everybody to be accessing that container, for example, if they're not authenticated.
Absolutely.
There have been examples of companies losing data or compromising users' data by putting stuff in insecure storage. Whether it's Amazon S3 or Azure, we have plenty of customers and plenty of examples that show that people will put either insecure data in insecure locations, or even private data that's supposed to be secure in insecure locations.
And so the last portion of this that we'll cover that I also think is real interesting, the other principle that we'll talk about is assume breach. And you kind of talked about it. I should say you just kind of broached it for a second. Is assuming breach. We want to limit our user access. Or excuse me, we want to make sure that we just assume that something has been breached, that there is a problem, and that somehow or another we need to secure it before anything ever happens.
Yes. And sometimes not even breach, right? Let's say I'm trying to access my HR details, like my salary or something like that. I'm in the office,
Sure.
I'm trying to log into HR web, and then I get a call, an emergency happens. I have to walk out of my desk and I leave my computer unlocked. And then somebody walks by, it's like, oh, let's see how much money Christos gets. Now, in our systems, there's this kind of escalation of privilege where when you need to access private resources, you need to access private data or sensitive information, we will prompt you for another authentication, whether that's through Windows Hello or whether that's through re-entering your credentials, just to make sure that it's not some random person accessing your machine. Now, that could be somebody that walks by my desk and sees my computer locked. It could be somebody that has breached into my device and they can get access to that information. And therefore, I love the fact that this is implemented. Security in layers is always important. Just because somebody has authenticated to your app, it doesn't mean that they should access all the data in your SQL database or your Cosmos DB or your storage. So you either prompt them if they need to access data, or you give them very few privileges to do something unless they have a different role. Maybe they have to re-authenticate and sign out, sign in back with different details.
So we're minimizing our blast radius, I think.
Exactly.
Is the thing we're trying to do.
Yeah.
All right. So Christos, before I want to start seeing what you got for me, I know you've got some really interesting stuff for me today about working secretless, and I'm going to ask you in a moment how to define that.
Sure.
But before we do, I want to remind everybody, we have a poll. We put up the poll every week and try to get a little bit more information about what you're doing and how you're doing it. So does your organization have a security standard for passing credentials? It's a really tough question that's, luckily you can anonymously answer it. But, that it's complicated answer definitely is probably going to be pretty common. And then we also have, if you go to the right rail, you'll see that we've got links for today's show. So you can check out everything, including links to how to find Christos online. And if you just like to ask us a question, you can see right here, I can say, hey, everyone. And I will have my chat have my message in the chat. You can reach out to us. We can find them. And so voting is as simple as, there you go. So it looks like so far everybody does have a standard. I want to talk also real quickly before we get too deep in that Microsoft Learn. It's a tremendous place to get some free education. Even on this subject, I think it's really, really useful. One of the things that I think you should take a look at today is the managed security operations in Azure, because that's kind of what we're going to be doing today. So you can get this, it's free education. You can see up here on the right, it's gamified, so you can go ahead and compete against your friends. I always like to say I'm a level 10 wizard in Azure. Hope you get your XP. And so now, Christos, I'm going to kind of lean into a blog post that you worked on recently. Not recently, but about a year ago.
Just a year ago. But
just a year ago.
Secretless is here to stay, my friend.
Yes. And it's Secretless Azure Functions development with the new Azure Identity libraries. And this kind of brings in the idea of the big thing that we want to talk to about. And this is the blog post that kind of like really, really got me interested in all this. So I guess the big thing I want to ask you first, Christos, is what do you mean when you say secretless?
By secretless, we mean that we want to eliminate any secure keys or API keys or secrets that need to be used by the application to access other resources. And it's very common to walk into random companies, which I did many times over the past 2 years working as a field engineer for Microsoft, where we went in to look at the code, help them build better solutions. And you had web configs or config files or JSON files littered with that information. And what was even worse is that not only developers had access to those secrets, but sometimes these secrets were used to access production environments. So there was a lot of responsibility on the developer to make sure they don't screw up with those secrets, like securing them and what have you. And then also a big challenge for companies because they did not have this kind of data management or data processing where if somebody left the company, they would roll out their keys, which was challenging, right? Because if you have keys littered all over the place and you have secrets in your web apps and your older apps and your desktop applications, and they all access different systems, starting to roll and centrally manage these was always a problem. So now somebody leaves the company and they still have access to their production environment. I knew that somebody that left their company 2 years later, they could still access their admin portal for their web solution, which was scary when you think about it. Now,
that's terrifying because, there are malicious actors sometimes. You can also have things like corporate espionage, people trying to find out what the secret sauce is to your application or your website info, data breaches, which are really, really scary. Nobody wants their data. And like I said, there could be malicious actors that want to actually destroy what your company's built. And, I can say, like, I've known a situation where someone did that to a company. They went ahead and they said, you know what, I'm mad at this place. I don't work here anymore. I'm going to really, get back at them. And they went and they deleted a whole bunch of network routes because even after they were let go, nobody spent the time to consider how do we remove this person's access to all these services and all these like network devices. And in the end, they learned really, really, in a sad, ugly way, how this happens. And you know what? I even heard about a virtual machine provider, well-known VM provider that a couple, maybe about 10 years ago, something like that, they had an intrusion that allowed someone to come in and get some particular credentials and destroy the business. The business did not exist anymore once this person finished with destroying what they had. And these are the things I think that, and the stories I think are worth telling people. Because something as simple as accidentally checking in some credentials into like a GitHub repository or an Azure DevOps repo, if it's public, you could be dooming yourself.
Well, I've been there. I've done that. I woke up to an email from SendGrid at some point saying, you've hit your quota for the month. You sent 30,000 emails. I'm like, I must have gone viral overnight. And then in that email, they also include information like, did you check in your keys into GitHub? And the light bulb went out. I was like, God, man. Because I had a blog post I had a blog that was running on Ghost platform, and you can integrate with SendGrid. So when somebody signs up and subscribes, you can send them an automated email. I was like, yeah, that's perfect. And that's what happened. So it can be totally accidental. It can be malicious. Also remember that cybercrime and cyber attacks a lot more. They're evolving quite a bit in attacking these kind of the easy targets, right? Why try to take over the web browser or the operating system that has undergone a significant amount of security when I can actually find the credentials in GitHub, or I can socially engineer a user to giving them to me.
Humans tend to be the weakest link when it comes to security. There's so many tools, scanning services, you name it. Like
keyloggers,
whatever. There's such a great way of thinking about it. Like if GitHub emails you and says you have credentials, like if you're subscribed to one of those services that actually looks, you need to kind of think about your practices, your procedures. Like I was going and doing Ignite the Tour demos.
Mm-hmm.
And during my Ignite the Tour demos, I had to actually build, demo environments, and I wanted a Cosmos DB database.
Yep.
And I realized that I checked in the key. And that's super dangerous, because that means that if I have that open to the world, now someone's got credentials to actually go in and do something with my Cosmos database. And we don't want that.
No, we definitely don't want that. We want to eliminate the need to check in secrets to begin with. And then we also want to use the least privilege approach, where our application is running under a context that only allows them to do certain things. And you might have different keys or different contexts within your application that can do different things. I have a funny story from back in the day where I was working for a company as a consultant, and the access to the database, which was a SQL database, and it was still using SQL login, was simply SA with no password. And when I asked, that was like across all environments. So when I asked, they were like, well, it's easy. We don't have to remember any passwords, and we don't have to manage passwords. It's like, yeah, that eliminates so many problems. And, who would think that is to say without password, people will try for days trying to crack the passwords when in reality there's no password. But it's this kind of practices that people need to also question, right? Why are we using SQL login when we can actually use Azure AD login now for Azure SQL, right? Why not use that? Why not use things like, as we're going to see very shortly, managed identities to access these resources without us having to actually provide credentials explicitly to the application. And the application can run in the same kind of way in dev, and when you move to QA, that exact same code will run, but under a different context, and then in production will run under different context. And moving those keys outside your application also allows the developers to be more agile. Somebody manages the secrets for them. All they have to do is just reference those keys and bring them back. Now, if you really, really want to attack things, then you can also do runtime debugging, right? You could be actually capturing the key over the wire, or you could be taking data dumps and memory dumps from the application to actually, access those keys. But at least they're not in the code. They're not easily found. And if somebody is actually on your VM taking memory dumps, then you have much bigger problems than just accessing keys, right? So again, we're trying to eliminate and provide these kind of layers for developers to build securely, but they don't operate in isolation. It's your network security guys, it's your IT admins, it's everything.
Absolutely. So I want to talk to you a little bit about, and we did a whole show about managed identities, but how do managed identities fit in to this secretless kind of idea?
Yes. So what our teams have done especially in the Azure context, is because managed identities are available technically only in the Azure context, although we will mention that there are some exceptions to that. In the context of Azure, managed identities are backed by Azure Active Directory. So those managed identities can have RBAC permissions applied to them. And therefore, when an application is running in the context of a managed identity, then it means that managed identity, or those managed identities, you can have multiple managed identities per application. So you can have multiple assignments. It means that those managed identities can be used to access different resources with very locked down permissions, like very specific scopes. So for example, we can have 3 managed identities in our solution, one of them to manage and access SQL, one of them to access SQL data, one to access Cosmos DB data, and one to access storage data. And then they will have all very different permissions. And they can also have like an admin managed identity that can access all these and do writes rather than just reading data out, or do some more privileged operations. So from that perspective, I think managed identities are awesome because they're an Azure resource. It can be managed centrally by your IT team. So you as a developer don't really have to worry about how that's working. But at the same time, you might say, well, I'm not running on Azure all the time. I'm developing local in my machine. So how is that going to work? Sorry, go on.
So yeah, that kind of leads me to ask you this question, which is, do I need to run on Azure to benefit from this particular security solution using Secretless?
No, you don't need to run on Azure, although running on Azure makes things a lot easier. The fact that most of the backend services, and by backend, like supplementary services like Cosmos, storage, queues, service passes, functions. Although functions are not as much as a backend, if they're APIs, they are. SQL, like all these important services are now fully integrated with Managed Identity. They are fully integrated with Azure AD, and therefore, what happens is your application could be running on-prem, and it can benefit from a local sign-in or a user that is maybe a service principal is signed into your local environment, and then that identity gets propagated to Azure to allow the application that's running outside the Azure environment to authenticate against that. You could also use things like Azure Arc. So if you're running a VM and that VM is joined via Azure Arc outside of Azure, it still feels and behaves like an Azure VM, even though it's running under your desk. And therefore, Azure Arc gives you a managed identity out of the box. I know that at Build, we announced a lot of PaaS services running on Azure Arc. And my first question, when I saw that, I was like, I jumped out of myself, like, yes, that's amazing. Where's my managed identity? That's in the works. It's coming. So if you're running Azure Arc PaaS services outside of Azure, you will also get a managed identity to allow your managed identities to allow you to access resources like that.
Speaking of Azure Arc, I actually had a meeting earlier today with Thomas Maurer, and the work that he has done to promote like the value of using Azure Arc to kind of create that single pane of glass for all your environments is really cool, and it helps kind of create a, say, multi-cloud or multi-environment or hybrid environment type of situation that keeps your visibility into everything available. So I want to get some visibility into this today, Christos, and I know you've got some demos to show me.
We do.
But before we get into the demo, I just want to remind everybody, if you've got questions for Christos, because we've got about a half hour or so to go, please put them in the chat. We want to hear from you. And if you'd like to, like I said, go ahead, please take our poll. Does your organization have a security standard for passing credentials? And if not, we need to make sure somebody talks to you. Maybe Christos will talk to you sometime in the future about how you can get that kind of policy put into place. Anyway, Christos, I'm going to bring up your screen.
Sure.
And I'd love you to kind of talk me through exactly what we could do to make our applications passwordless.
Yeah. So the foundation of doing most of these things that we're going to be talking about is coming through the Azure SDKs. In fact, there's one library called the Azure Identity Library, which can be seen here, not here, but here. You can see it. I'm using the Azure Identity library here. And this is available in every language that the Azure SDK is available as well. So if you are using, say, Node, which we'll see at another demo, if you are using Python, if you're using Java, if you're using .NET, you can benefit from the exact same model. And they're also using the exact same kind of an API declaration. So if I am creating a token credential in .NET, it has the exact same kind of declaration inside Java. It is idiomatic to Java or it will be idiomatic to Python, but the principles are the same. So in .NET, we've done even more work to make it more integrated. So one of the things I mentioned earlier on is that configuration settings are usually a big challenge for developers and companies because they have to put things in configuration, and it's not something that you can pull at runtime. You can't say, well, you load the page, and then after you load the page, after I know who you are, I want to go and pull a secret from Key Vault, right? So in .NET, we have a bootstrapping operation that allows us to actually go and call into Key Vault from .NET to populate our settings in our config. So in here, in my app settings, I have some config value from Key Vault. This could be blank, in fact, doesn't have to have a value here. We can leave it anything, but if it was a secret, we would remove it from there because we don't want any secrets there. And the expectation is as the application bootstraps and I need to use that value, it will be pulled from Key Vault. How does that work? So if we go into our program.cs, if you are doing .NET, by the way, and I will explain how you would do it in Node in very shortly. But if you were working with .NET and .NET Core and ASP.NET, then during Bootstrap, we can actually call into Key Vault. There's a library It's a key vault configuration provider that allows us to point to a key vault, then pass the credentials. Now that's the key here. And then it will actually populate the config settings where it finds a match. It needs to match on the wording. So this one here also exists in my key vault. If it doesn't find any matches, then it will just ignore them. So it won't populate this one. But if it finds one, it will try to overwrite it. And then from key vault.
And so allowed hosts there, I'm just curious, is that like, say, a network rule specifically where
this is for cores. This is for cores, not for anything, but this is not specific to anything that we're doing with security today. Now, as I said, the key here is the credential provider, right? So as you can see, I'm instantiating a key vault instance, and I'm saying, go and look at that key vault, but I'm not passing any keys. I'm not passing any secrets, which was usually the norm maybe up until 3-4 years ago. The nice thing here is I'm saying, use the currently logged in user and go and access my key vault information. And you can be super inclusive. You can say, I want to use the default Azure credentials. So it will try to find everything under the sun. It will look for environmental variables. It will look for your Visual Studio credentials, your PowerShell credentials, your CLI, Azure CLI credentials. It will look everywhere. And there's a whole set of credentials they will look at. It's very well documented. But I don't like this one. I don't like this approach because it's super inclusive. So it might pull a credential that I haven't defined, or it might be authenticating with the first one it finds and it might not be the right one. I usually like to be super explicit. So I use either 1 or 2 credential providers, and that's the chain token credential. So the chain one says, try in an order to find the appropriate credential. If you don't find anything, then you fail. And as you can see here, I'm using the Azure CLI credential. So if I switch to my terminal and I do Azure account show, it will show me which user is currently logged in. And as you can see, I am logged in as myself. Now, this is a no-no, and I will show you how to do it better. But currently, I'm logging into my CLI as myself. And that means I have super privileges on my Azure subscription. Remember, we talked about least privilege. This is not a good account to use when you're creating applications, when you're running against Azure, because I can go and delete my key vault. I can go and delete resources. I can go and write everywhere. So this is not a good account. And I will explain how we can solve this. So with this account now, when my application starts running, it will try to find these credentials, and then it will say, okay, do these credentials have access to key vault? This is very important. Remember, we have layers. I might be an owner of everything on my Azure subscription, but that doesn't mean I can actually go and pull secrets for my account. There needs to be an access policy inside Key Vault to allow this account to go and pull credentials. So that's a nice feature that you have to do, because sometimes you might say, well, I created the Key Vault, I put all the secrets there. Why is this library not working? And we're doing this here, right? So we're bootstrapping our config, which is great. And then later on, we have another page, which I've created, that we actually pull some secrets on the fly as well. Okay. So here we have another kind of config. So you can see in here, we're going and getting some config value from Key Vault. Remember that this is defined in our config, and we're pulling it directly. So our configuration has been populated at startup, and now I can call it. I can pass it here. But I also want to pull a Key Vault value on the fly at runtime. I want to be like, hey, for this page, I want to get some extra information, and I don't want to put it in my config. I want it to be explicitly called here. So again, I'm instantiating a secret client. I'm passing my credentials. Remember, we could also cast those credentials. We can put them in our startup and then make them kind of a single instance, or make them static, so we can pass them around so we don't have to instantiate them all the time. And then here, I'm just grabbing the secret value, and then I'm passing it to the page. So let's see this application running and how it looks like. So this is a .NET application, which runs, now it's running locally in my machine. I'm using my local Visual Studio Code. It could also be Visual Studio. I haven't tested this actually in. So as you can see, if there was a permission issue, it would fail to bootstrap, in fact, because it wouldn't be able to start up the application. If you see this when you deploy it to production, then it's usually an issue with your credentials. And then we'll go to the page I was just talking about. And in here, you see I've got my hello Azure. Oh, sorry. I am sorry. I'm just talking to myself now.
There we go.
Sorry, home. There you go. So this is our home. If you bootstrap the app, if you start running, that will be what you see first. And this is what we were pulling out from our config, which was populated as startup. And then in my Key Vault secrets page, which we're just talking about, I have a nice, funky, topical message. Hello, AzureFunBytes. And then again, that same secret here. Now, if I were to go and change that secret from, wait a minute, I had my portal somewhere. Where's my portal? I have too many windows open. Let me find my Azure portal. You know, they changed the Azure portal to be the same. Well, you know what? We can jump here.
Well, you know what? We got one of our users, who answered our poll, and he was saying, yes, he is using that kind of standard, and that standard is via HashiCorp Vault. And so while, Key Vault, a perfectly great place that's Azure native, there are also third-party tools so that if you want to have something that'll work on any provider, anywhere, you can go with that. You can even run Key Vault on Azure. It's up to you, or I should say HashiCorp Vault on Azure. It's really your decision. In the end, I think we just want you to use one of these services. We'd love you to use the Azure service, but I believe that no matter what, we want you to use one of these services and ensure that you're taking part in creating a more secure internet.
Absolutely. It does have to be Azure, right? As long as you use something that can be centrally managed. Now, what I did here as you were talking is I went in and I've changed my secret value. So let's say an IT admin says, we need to roll our keys without breaking the applications. They will come in, they will change this here. And then if I go back to my page and I refresh this, then there you go, changed during runtime. So while the application was running, I was able to change that the code needs to access that secret. They will get the latest version, which is great because my admin may roll the keys to an API, right? And I will be totally oblivious to that. I don't even need to know what the key is. It will work. They change the API key on the source, and my application works out of the box. Now, this is running locally, which is great. You might say, well, you prove that it's working. What about Azure? What happens when you go to Azure? And that's a great question. I have deployed this same exact solution. I think it's under here. So let's run this. Let's browse that page and see what happens.
Sure. And while you're doing that, there it is. Before I didn't even have a chance to.
Oh, you know what? Yes, this is actually showing different value here, right? Because the last time I ran the demo, I haven't restarted the app since then. So remember, this gets populated at startup, at config. So I need to restart to get that config change propagated to the code.
Sure. So to inherit those values in order to make them available to the application.
Because
you have to reinitialize it.
Yes, because a startup, it only reads the config from Key Vault once. And if it changes, then you need to restart the application for those changes to take effect. But the one that was a runtime will always be reflected in the page as we access that page. Doesn't require a page restart. Now I know that sometimes web app restarts are notorious because they're a little bit slow, and sometimes you freak out because you think that you broke the website and oh my God, it's not working, but it's not the case. So that's
why we do CI/CD, right? So that we can feel some sort of comfort when we make these changes.
Hey, remember those days of IIS when you were running things in production and you had to wait for IIS to load? There you go.
Yes, or the scary restart Apache if you're using a Linux machine where you Apache CTL restart and then you'd be like, oh, please work, please work.
Please come back. Please tell me that nobody has changed anything in the config or something in IIS that will break everything. But now you might say, well, how is Azure running? Locally, we're using the Azure CLI credentials. And if we jump back into the code, you will see that our chain token credentials have two credential providers. One is the Azure CLI, which I'm using locally. And then we have the managed identity credential, because on Azure, we're not signed into the Azure CLI. So I need to find something. So you can have an Azure managed identity credential, which needs to be configured across the board. And what I mean by that is that in my application here, I have an identity. That identity, you probably covered this before. You have a system assigned one, which lives with the resource, and then you have a user assigned one, and you can have multiple of these. You can have like 10 user assigned managed identities that you pull into your application. And that identity here is the context that the application is running under. If we jump into our Azure role assignments, it might show us that here, or we might have to jump into, it doesn't have any role assignments because this is part of Key Vault. So in our Key Vault, if we jump into our access control, it's access policies here. There is an account once it resolves that. Remember that website we're running, cm.net conf demo? That is our website, and that is a service principal that is running that website. And here we only have 2 permissions. We have a get and a list. So that website cannot delete or edit or update any keys. You can only read them and provide them to the application. So that's our list privilege over there.
Very cool. So we've kind of covered this, and I wanted to bring in a question.
Yes,
because that'll lead me into one of the others. So I've got 2 questions for you. The first one I want to ask is, can we use this approach with any language?
Yes. In fact, my other demo is using Node. And it's doing more with Node, in fact. So remember how we said that it's going to be very, very similar in the way that we define our token providers? Check this out. Credential. New chain token credential. You might think this is .NET, right? But it's not. It's TypeScript in Node, and I'm using an Azure CLI credential. I also use the Visual Studio Code credential here if I wanted to. In fact, I have an account here that is already signed in. So if I didn't find anything in the CLI, I would use that, and then I have a master identity credential for when I go or want to go live. So in the same exact way, you see there's a lot of similarities here in how we engage and how we work with the Azure Identity Library, but that's all you have to do. And then you just have to pass those credentials when you instantiate a blob service client. You pass the credentials with the endpoint, and it all works. No secrets.
Very cool. And so, that really is leads me into a question that we got from Gregory in our audience. And Gregory wants to know, can managed identity can it be added to use SQL DB, so not SQL Server, but using, say, Azure SQL? Can we use managed identities to be able to, say, log in, manage our Azure SQL?
That is not for managing. Well, there's 2 data planes. Sorry, there's 2 planes when it comes to Azure. There's the data plane, which is accessing your resources, and there's the management plane, which is for managing resources. For managing resources, I don't think you can use the Azure identity. You can use a service principal to do all that and automate things, but you can use managed identities for managing resources. You can use managed identities for accessing your SQL database. In fact, if you are in .NET, and I was planning on doing a blog post on that, SQL client, the MS SQL client library 3.0 and above supports the Azure identity out of the box. So you can say, I want to sign in with the default Azure credential, and then your SQL connection, whether it's through Entity Framework or whether it's directly through SQL client, it will actually inherit that information and will work out of the box. And SQL now also supports Azure Active Directory authentication. In fact, you can disable, well, you cannot disable, but you can enable Azure AD only authentication to your Azure SQL, which means that you don't have to, when you provision an Azure SQL database, you don't ever have to pass the credentials anymore. You don't have to pass SQL credentials. You can say, I only want to use Azure AD. And that's fantastic because it brings the Azure AD data plane into that. You can do full RBAC on your SQL database. And Julie Lerman has done a fantastic blog post that explains how to set it up. In the old days, I also have a couple of samples in my GitHub repo, which I think we've put a link here on the 45 show. So you can go there and see how we implement it ourselves. And we even put a helper there before SQL Client 3.0 to do the bridging of the gap between Azure Identity and SQL. But yes, now the long answer is that yes, you can do that now.
Very, very cool. So we got about maybe 15 minutes or so. So what do you want to show me?
Well, let's run this demo because this one is doing more than just the previous one. The previous one was only calling into Key Vault, and it was just pulling data in. But in this one, we're actually showing how to work with Cosmos and storage and Key Vault, and even we have a SQL client, sorry, not a SQL client, a graph call. So we're calling Microsoft Graph from the API. So the API is actually acquiring a token on behalf of the user, and then it calls the data for that user through Azure Active Directory. So if we were to run this one, let's run this bad boy. Now, one of the things that, in fact, I was updating the code yesterday, right? Because I noticed that in my code, I was such a bad boy. I put the client secret in here. And I was thinking, I cannot check in that code because I don't want the client secret to be exposed. So we revert back to Key Vault. So I need to call Key Vault. And remember, we said in .NET, as part of our bootstrap, we actually called into Key Vault to populate some values. So here, as part of our bootstrapping as well, we get the client secret from Key Vault. And what we're doing, check out, I mean, it's 2 lines of code. It's insane how easy it is, right? We say, get me a new secret client. That's my Key Vault endpoint, and these are my credentials. And now go and get me the client secret for my MSAL authentication, which is just mind-blowing how little it takes to implement security, eliminate secrets, and then calling into services securely. So with that, let's go. Cool. Let's go and do it. So no secrets in this. I mean, I was going to do the demo, and then I said, well, I have an MSAL client secret there. This goes against what we're supposed to be doing or showing. So, oh, yes. Now, why did we get an issue here? Well, we got an issue here because currently my Azure CLI is logged in with a different account. And I'm using a different cloud. In fact, I'm using a different subscription, which means that my account, this account that you see over here, is not actually signed into that account. And because the Azure Identity is trying to sign in, it says, well, this is their own tenant. You're trying to sign in with their own tenant. So let's go and sign in. I think I have it here. Let's go. Do not use my secret. I'm just kidding. So now I'm in a different tenant. So that's a different Azure AD, and I'm using a service principal. So I mentioned this earlier on. Remember, I said, do not use my account. This account has a lot of privileges, and that means that I'm a full owner. Whereas this one has actually been configured to only have access to my Key Vault, to my Cosmos, and to my storage account, and nothing else. So
least privilege access.
Yes, exactly. And even in those resources, it was only provisioned to read secrets from Key Vault. It was only provisioned to read stuff from Cosmos, and it's only been provisioned to read from my storage. So it's a very low privileged, very restricted account. Somebody compromises these, like somebody says, oh, well, you know what, I've got his secret, which I will rotate in a second, but hey, I've got his secret. Now I can go and do nothing, right? Okay, so here they can go and read my insecure data, but at the same time, they can't do anything else, which is great as an example showing how you can achieve that. And if people are asking how I did it for Cosmos, because Cosmos does support, they don't have all their roles defined out of the box yet. So if you are working with Cosmos, then you need to create a custom role and assign that custom role to your custom identity in order to say exactly what it can do. And as you can see here, it only provides you access to read metadata and execute queries. They can't do anything else. So now let's go and sign in with that account, which I've already signed in. So let's go and rerun the application.
Okay.
And see if it works. And one of the things they tried to do was actually go and get the secret from Key Vault, because that's the first thing it attempts to do. And that didn't work. So it's running again. Holding my breath. Okay.
Oh, there we are.
We have a liftoff. So let's open our Thunder client. I don't know if you've used Thunder client before, but it's one of my favorite tools. It's great because all you have to do is just it's in VS Code. It's built in.
So it's like a built-in VS Code postman, if you will.
It is. And in fact, you can even do authentication. And we're going to do authentication because our APIs, check this out, it's not just a secure API. So it's not just an API that accesses data securely, but it is also an API that will check for a valid JWT token. I need to authenticate first so it knows who I am. And I need to have the right scopes in order for me to be able to access that. And once I have my right scope, then it will go and get the data, which is, remember what we said, we need to know who the user is. Authentication, authorization are basic components of our security. So for that, Let's go and authenticate very, very quickly. It will ask me to sign in a different page, so don't worry about that. I mean, I can show that. So here it says, which account do you want to use? We want to use the account that is designed to work with that tenant. We'll say success.
So the one with the right access level.
Exactly.
Gotcha.
And then now that we have the token here, we can go and call our, in fact, let's go. I even put a helper method there. See, we have blob storage. So let's call our blob storage. This is going to Azure Storage and lists some details. And we have, I think it was Cosmos. And then this will pull some Volcano data that I've put yesterday. And we can see all this information, again, with only read-only permissions. And I think I had another call, which was called Volcano. And then I had to pass the Volcano name.
Okay.
This will do a query to one item only rather than getting everything back. And then finally, graph. So this is where the API will go and authenticate against Azure AD. It will pull the appropriate information out of Azure, and then will return the metadata for my account. So it said, go and get me some graph data for this user, which is great. But what I want to say is that the code that actually does all that work is 4 lines, right? Like verify that the user has the right scopes. There's a helper method here to validate that the incoming call has the right token. And then from there on, I am calling into I'm using my Azure SDKs to call into the individual services and dump them out. So all in all, this application can do a lot of things with a lot of Azure services. And there's not a single secret here, which is amazing, right? And by the way, client IDs and tenant IDs are not secret. If you have them in code, it's absolutely fine. Nothing to be ashamed or worry about. So there you go. Any language,
awesome.
Any platform. And
hey, just like what we say about Azure DevOps, any language, any platform, anytime, anywhere. Absolutely.
Yes. And we have a whole DevOps section about how to secure DevOps with managed identities and service principles and all that jazz, because we have the code. Now, how do you deploy the code? How do you deploy those services securely to your environments without compromising secrets? I said before, just prior to the latest version of Azure SQL, you had to pass a username and a password. Which you had to put somewhere in your config. You can pull that out of Key Vault at deployment time, and you probably have done this before, but there's a whole other section of security deployment and auditing and managing production systems.
So, Christos, we only have a few minutes left. And I wanted to kind of get back to some stuff about you for a second, because we've gone through all this code, we've gone through it, and like I said at the top of the show, people are a big part of the show and talking about the people that make up a great Azure experience. And I want to actually know a little bit more about what you're excited about when it comes to the identity space. So what are you most excited about right now in identity?
I would say that from an identity perspective, there are 2 things that are coming as part of new RFCs and new standards. And that is the continuous access evaluation, which means that when somebody authenticates and gets an access token to access resources, we don't really have an easy way to check whether that user is still with us. So a very good example, which is also a sad example, is like I sign into my Outlook this morning, and then my manager calls me within 5 minutes and says, well, Christos, it's been fantastic working with you, but we had to let you go. Now, at that point, I don't have access to Azure Active Directory anymore. I've been taken out of the network, but I still have my access token to my emails. And that will take an hour before that email can be revoked. Sorry, that access token can be revoked. With continuous access evaluation, we can build systems that when an access token is passed, it can get evaluated whether that user has met some criteria. And if that user is not part of the domain anymore, that token gets automatically revoked. So rather than the application going, do I have access? Do I have access? Do I have access? The Azure AD or the identity system will say, you don't have access, you don't have access. You try to pass something, I revoke that. And that means Outlook now can issue a 48-hour token. Doesn't really matter, because every time I try to access, Azure Active Directory will intelligently look into the token and say, well, you don't have access anymore. That user doesn't have access. And the other one is token binding, which is improving the security of tokens and making sure that only the client that has actually acquired the token can use that token to call services. So that's another awesome feature.
Very cool. And so I also wanted to ask a little bit about the fact that you do some social media and some blogging and some shows. And so one of the big things and we can see it in the background that you have, and of course on Dev too, it's the 425 show. And I've got a link to the blog right up here, and you can check it in the show notes. Why don't you tell us, everybody, just a little bit about the 425 show?
The 425 show is a Tuesday and Monday show that we go on Twitch and Periscope and YouTube, and we talk about identity and security across the board. End-to-end scenarios, how we can help you build secure apps, any language, any platform. So it doesn't really matter if you're using .NET or Python or Ruby. We'll try to help you build secure solutions. It doesn't matter if you're running on Azure, it can be on-prem, it can be on some other cloud, but the whole point is to be able to help you build these things. So 425 show is the place to be on Tuesdays and Fridays at 8 a.m. Pacific time.
And so you've also done some great stuff for a bunch of different shows. I know that this was a great appearance using Azure Managed Identities for the .NET show. I think that one of the things that we talked about is the fact that this is for any language.
Yes.
And so, .NET, Node, Java, you name it, making sure that you're doing correct security policies and practices are going to make sure that your users feel confident and make sure that your reputation of your business remains. And that's a big part of security is reputation defense, if you will.
We don't want you to make the news. That's it. That's our motto. We don't want you to make the news for their own reasons.
Absolutely. So the poll results are in, and let's see, 67% of you said yes, that your organization has a standard for passing credentials. And I think that that's really, really cool to see that a majority of us have that. We've got one of our viewers. He says, "Thank you. Great information. Thank you for watching. We really appreciated having you part." So Christos, we've got about a minute left, and I wanted to just ask you before we go, is there anything interesting coming up that you want to tell people about and how they can get in touch with you online?
Find me on Twitter, find me on Twitch. That's the best place to find us. And we always announce things there. So make sure to follow.
Awesome. Well, that's just about it, Christos. I really thank you for your time. This was a great session. I learned a lot more about managed identities, and I hope our viewers did too. We'll be back again next week. I've got even more security stuff coming up. I'm going to have Tanya Jenka, who is part of We Hack Purple. She's going to be here, and we'll learn a ton more. So for myself, for Christos, thank you so much for watching. I will see you next time here on Azure Fun Bites. I'm Jay Gordon. Thank you so much for being part of this show. I can't do it without any of you. So we'll see you next time. Bye-bye.